In this video, we want to learn how we can find the determinant of a 2 by 2 and a 3 by 3 matrix. Let us start with the simple one, a 2 by 2 matrix. Consider this 2 by 2 matrix A, B, C, D. This matrix has 2 rows and 2 columns. We show the determinant of a matrix with this symbol, or sometimes instead of writing this, we write determinant of A. And the determinant of a 2 by 2 matrix is simply multiply A by D, so A times D, minus B times C. This is how we define the determinant of the matrix A. The determinant of a matrix, as you can see here, is just a number. And this number has important properties about that matrix. For example, if the determinant of a matrix B equals 0, that matrix, that original matrix, is not invertible. But this is not the topic of this video. Anyway, the determinant of a matrix is just a number which we can calculate for a 2 by 2 matrix from this formula. Let me show you an example. Suppose we have this matrix, negative 1, 2, 3, 4. Then the determinant of this matrix equals to negative 1 times 4 minus 2 times 3. Negative 1 times 4 is negative 4, 2 times 3 is 6, negative 4 minus 6 is negative 10. Let me show you another example. Consider this matrix, negative 1, 3, 5, 0. What is the determinant of this matrix? Determinant equals negative 1 times 0 minus 3 times 5, which equals negative 50. As you can see, finding determinant of a 2 by 2 matrix is really simple. Now let's find determinant of this matrix. 3, 7, 10, 5. Note that if we put a square brackets like this around the number, it means we have a matrix. But when we put only vertical lines like here, it means that we want to find determinant of this matrix. So now it's not a matrix, this is just a number. This is a real number because this is not a matrix. If we put a square bracket like this, this is a matrix. But when we only put vertical lines, it means that we want to find determinant of this. And determinant equals 3 times 5 minus 7 times 10. 3 times 5 is 15, 7 times 10 is 17, 15 minus 17 is negative 55. Now that we are a bit familiar with the determinant of a 2 by 2 matrix, let's see how we can find determinant of a 3 by 3 matrix. Consider this general 3 by 3 matrix A, B, C, D, E, F, G, H, I. We define determinant of this matrix in this form. A, this element, times by, delete the row and the column, ignore this row and this column, multiply A, this number, by determinant of this part. Note that here we have a 2 by 2 submatrix. So we multiply A by determinant of this part. So determinant, remember this means determinant, not a matrix. Determinant of E, F, H, and I. And we know how to calculate this. Simply E times I minus F times H. This is a 2 by 2 matrix. Then we are not done yet. Minus, always minus B times by determinant of, again, delete the first row and the column of B. What remains is D, F, G, and I. So minus B times by this determinant. And finally, probably you can guess what is the next term that we have to put here. Plus C times by determinant of, delete the row and the column of C. Ignore this row and this column. So what remains is D, E, G, and H. This is how we can find determinant of a 3 by 3 matrix. As you can see here, finding determinant of a 3 by 3 matrix has a lot of computation. In the next video, I will show you how in general we can find determinant of a n by n matrix. But in this video, we want to learn only determinant of 2 by 2 and 3 by 3 matrices. This is how we can find determinant of a 3 by 3 matrix. Let me show you an example. Consider this matrix. -2, 3, 5, 1, 4, 0, 3, 1, 7. We want to find determinant of this matrix. Determinant of this matrix equals to A is -2, times by determinant of deleting this row and this column, 4, 0, 1, 7. -3, don't forget to put a minus here. It's really important not to forget this. Minus this number. If this number is negative, then here we get positive. So don't forget to multiply this minus in this value. Minus B, which is 3, times by determinant of deleting the row and the column of that element. What remains is 1, 0, 3, 7. And finally, plus 5 times by delete the row and the column of 5. What remains is 5, 1, 4, 3, 1. Now let's calculate these determinants. -2 times by, this is a simple 2 by 2 determinant. We know how to calculate this. 4 times 7, which is 28, minus 0 times 1, which is 0, minus 0. Minus 3 times 1 times 7 is 7, minus 0 times 3 is 0. And finally 5 times 1 times 1 is 1, 3 times 4 is 12. This equals to -2 times 28 is -56. This is -21, and here we have -11 times 5, which equals -55. And this equals to -132. Let me show you one more example of finding determinants of a 3 by 3 matrix. But this is a bit different question. We want to find the value of x such that this determinant x squared, x1, 4, 2, 1, 9, 3, 1, this determinant to be equal 0. Note that this is not a matrix because we have vertical lines, not square brackets like this. This is a determinant, and we know that determinant is just a number. We want to find the value of x that makes this determinant equal 0. If we use the formula that we learned for determinant of a 3 by 3 matrix, we have x squared times by, note that the first element A is x squared, times by 2, 1, 3, 1, minus, don't forget this minus, x times by determinant of deleting the row and the column of that element. What remains is 4, 1, 9, 1. And finally, plus 1 times by determinant of deleting this row and this column. 4, 2, 9, 3 equal 0. This determinant is 2 times 1 minus 1 times 3 is -1 times x2. So finally from this we get only -x2. 4 times 1 is 4, minus 1 times 9 is -9. 4 minus 9 is -5 times -x is +5x. And from here 4 times 3 is 12, minus 18 is -6. equals 0. If we multiply both sides of this quadratic equation by a negative, we have x squared minus 5x plus 6 equals 0. And we can factor this as x minus 2 times x minus 3 equals 0. And from this, x is 2 and x is 3. These are the two values that if we replace here instead of x, determinant of this matrix equals 0. There is a different method for finding these values, but this is not the topic of this video. I hope by watching this video you have learned how to find determinant of 2 by 2 and 3 by 3 matrices. If you want to learn more about finding determinant of matrices, or if you want to learn why we define determinant of a 3 by 3 matrix like this, watch my next video, which I define determinant for a n by n matrix, not only for 3 by 3 or 4 by 4. If you learn the general formula, then you understand why determinant of a 3 by 3 matrix is like this. If you like this video, please subscribe in my channel. And thank you for watching.